Welcome back to Maths with Mrs. J. I'm going to start a new series of videos about probability distributions. To start with, I'm going to talk about probability distributions in general. I'm going to focus particularly on probability distributions of continuous variables. Then I'm going to move into binomial distributions, which of course are a discrete random variable, and the normal distribution, and even do some videos about the normal approximation of the binomial. So we're going to start off with distributions in general. You should know, hopefully, from your junior high school years, that if you are conducting an experiment of some sort or collecting data of some sort, the greater number of scores you have to collect, the more likely your data will represent a normal distribution kind of situation. So obviously, initially, you're going to have a frequency histogram that's going to look like this. The more scores you have, the smoother it's going to look. Now, a lot of distributions will be symmetrical. We know what symmetrical means. Mirror image about the middle of it. In a symmetrical distribution, the mean and the median and the mode are all in the center. If we have a positively skewed distribution, then we have I guess you could call it a tail at the positive end. In that case, the mean will be higher than the mode. If we have a negatively skewed distribution, we have a tail towards the lower end, our mean will be less than the mode. All right. It is possible to have a bimodal distribution. So let me show you what that looks like. That would look something like that. If you have a distribution with 3 equal top scores or more, we say that it has no mode. So once we go past bimodal, we say that it doesn't really count as a mode anymore, and we say it has no mode. Let's do an example just to start with of I guess a year 9, 10 kind of question where we're putting some data into a display. What we're going to do is what's called a stem and leaf plot. I quite like stem and leaf plots because they are a way of, I guess, tabulating data, ordering data, and giving a shape that the histogram would be. In order to do a stem and leaf plot, you've probably seen these before, but if you haven't, that's okay. They're not that difficult to do. What you do is you have a look at your scores and you see obviously what the minimum and maximum scores are, and that will then guide you as to what stems to use. We've noticed here that our absolute minimum score, I think, is 18, certainly in the teens anyway. So the smallest stem we're going to need is 1. And the largest score, just having a little scan along there, that we're going to have is 86. All right, so we're going to need stems 1, 2, 3, 4, 5, 6, 7, 8. All right, so what we need to do, because we're doing a back-to-back one, this is particularly useful because it helps us compare the distributions. Okay, doing class 9A, what we're going to do is we're going to scan along. You can take your time with this and cross them off as they go and all that sort of thing. Obviously, I've prepared this earlier so that I'm not going to fumble and take too long to find the various scores. We're going to, because we're doing a back-to-back, we want to move from the inside out. So we're going to put the lowest scores in here and move outwards. All right. Okay, so we're going to have a look at our data and we're going to put our results in going out that way. So our smallest score is 15, our next smallest is 18, our next smallest is 19. Then in the twos, we have 2 22s, 2 25s, a 26 and 2 29s. So I've tried to sort of put them in some sort of logical arrangement so that it looks a little bit like a histogram. All right, our threes, we've got a 1, a 3, a 3, a 4 and an 8. Our fours, we've got a 2, a 4, a 5, a 9 and a 9. Fives, we've got a 4 and a 5. And sixes, we've got a 5 and a 7. Sevens, we don't have anything, and eights, we have an 86. Now, by the way, with a stem and leaf plot, some books don't do it, but you really should do a little key to say what it means. So you should have a little key here to say that 1, 3 means 13, for example, because sometimes the leaves are not whole numbers. They might be a decimal. So 1, 3 might mean 1.3, for example, depending on the situation. All right, putting in our class 9B data just quickly. So we've got an 8 and a 9, a 2, a 3 and a 5, a 1, 4, 5, 8, 2, 7, 8, 9, 9, 0, 1, 3, 7, and then 3 8s. 5, 6 and 7 and a 4. Okay, now that's not perfectly neat. Ideally, it would be lined up beautifully, but time and all the rest of it, okay? That at least orders our results for us, so we know from smallest to biggest in each class. We also have a good idea of the sort of shape of the distribution. Let me just get a different color and I'll show you what I mean. So if you're having a look at from the side, notice how this kind of goes like that. Now, bearing in mind that this is the top end, not the bottom end. Normally we're used to the left being the bottom end, but this is the top end. This one is obviously positively skewed. This one here is pretty much symmetrical, really, I'd say. So I would say when it says comment on the shape, I'd say this one is positively skewed. This one is pretty symmetrical. Not perfectly, but it's pretty symmetrical. Certainly more symmetrical than that one. So we've done part A and we've done part B. Now we're going to have a look at part C. Now, to do part C, we need to know how to calculate these things. The range is very easy, so let's do that first. So 9A, let's do our for each class. So for 9A and for 9B. All right, so the range is always going to be your largest score minus your smallest score. So for class 9B, it'll be 74 minus 18, which is what, 56. Okay, for class 9A, our range, again, largest score minus smallest score. So it'll be 86 minus 15, which is 71. Fairly significant difference in those two ranges. Our median. Now, we have 25 scores for each class. So the score that we're going to want, the one that will be in the middle, will be the 13th score. How did I get that? I did 25 divided by 2, and then I rounded up to the next whole number. You can do 25 plus 1 divided by 2, which is technically better, but a lot of people get confused by that. Okay, so our 13th score. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for our 9A, it's a 33. For 9B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, it's 49. Now again, that's quite a significant difference. Now for the mean is always the sum of scores divided by the number of the scores. added these up in advance to save a bit of time, because obviously adding up 25 numbers is going to take a while. For our 9A, adding up our 25 numbers, we get 955. Our number of scores is, of course, 25. When you work that out, you get 38.2. For 9B, you get 1,137 over 25, which is 45.48. Quite a significant difference there, really. And a lot of that is because of the skewed nature of this data. Particularly notice how there's a big peak here, way down with low values. So it is quite significantly positively skewed. If they didn't have the 86, that would certainly change your mean to a lower value. And quite often if you have what are called outliers, so scores that are very different from everything else, we will omit those when we work out the mean. Okay, in our next video, we're going to start talking about continuous random variables and their probability distributions, what is a probability distribution, and all the rest of it.